What's up everyone, and welcome back to the fourth video in our NumPy tutorial series. In this video we're going to wrap everything up. We're going to be doing the rest of the basic functions that I feel like are necessary, and then from there we're probably going to jump straight into some basic machine learning stuff. So all of this NumPy stuff is in order to be ready to do some machine learning stuff. So first we do our normal import NumPy as MP, and then we will make some arrays like we have in the past using np.arange. And this time I'm going to do 8 items, and I will make it a shape of 2 by 4. And then I'm just going to copy this. And so now we have our arrays, both of them basically the same 2 by 4. And I'll print those out so we can show. Whoops. And so we've got our same 2 by 4. It's just 0 through 7. It's not anything special. So now that we have these, there may come a time when you actually want to swap the columns and the rows. You might want to be doing some comparison where you're kind of doing like a cross index sort of thing, or you might just need the dimension shifted so that you can do some matrix multiplication or something like that. So what we will do in that scenario, you have two options. You can just do the name of your array dot uppercase T, and that will do the transpose of your array, so it'll swap the columns and the rows. The other option is you can do np.transpose, and then the argument will be your array. And that's exactly the same thing. You have the option of doing either. If you do numpy.transpose, there are some additional arguments you can pass in, and you can decide to swap different columns and rows if you have different values you want. Or you can do numpy.swapAxis, but I'm not going to cover that in great detail right now. Right now, all we really need is transpose. And so that's pretty useful if you want to swap, but let's say that we have all of these values and we really don't care their dimensions. We just care that we have all the values all in a row. So like say if we want to turn it into a vector or something like that, so we can do a.ravel, and what it's going to do is it's going to just flatten the entire thing. So you can see that it turns it into a vector instead of a two-dimensional array. So this is really good for if we want to be doing some sort of input for like a neural network or something like that. This is what you need. You need it all as one long vector because you can't be doing this multi-dimensional stuff. And so you have that option, and then the other option is just flatten. And for our sakes, it basically does the same thing. We won't get into the differences right now. And so, using our transpose, we can do something like matrix multiplication, like I was talking about earlier. So we have two options with this as well. We can do numpy.dot, and then we have to pass in our two arrays that we'll be using, and we have to pass it in parentheses on top of the normal parentheses just for the function, because it needs to be a tuple. It needs to be a, b, or something like that. And so we'll do a, b, but if any of you are very familiar with matrix multiplication, you're going to know that this is not going to work, because actually the dimensions are wrong. You can't multiply a 2 by 4 by a 2 by 4. You have to do the transpose of one of them. So let's do the transpose of b. So b dot capital T. hang on, I have to go back, and actually we don't need the additional parentheses. We'll save that for a different function. So np dot dot, and then just the two arrays that you want to pass in. And so we can do A times B transpose, and we get what we expect because we're doing a 2x4 by a 4x2, and so we end up with a 2x2 as our output. Then what we can do is sometimes, like with the neural network, you might have a lot of input, and so what we do is we squash it all down to one vector. It's just one dimension, and then we want to stack them all up. We want them to all be in a row so we can pass all of the input through at the same time, and then we can use NumPy's broadcasting, which I'll talk about later, to run all of the operations at once very quickly. And so the way we do that is we can do Vstack or Hstack. And so I'll do Vstack first, and we can look at what that does. And so it again will take two arrays. This time it will be in the double parentheses because we're passing it in as a tuple. I'm going to delete these for now. And so you can see what it did is it vertically stacked them. So it took our first array and then it just stuffed the second array right below it, and it just stacked them up. And so alternately we can do Hstack, so we can do it side by side. So you can see that here's our first array, here's our second array, and it's just going to line them all up like that. And so for neural networks and stuff like that, we'll probably want to do something like this, where we can do dot ravel, and then we will do a vertical stack. And then you can see that we've got our inputs, they're flattened. We could do flattened or ravel, it doesn't really matter in this case. And we've stacked them up so that we can pass them into a neural network, and it can do something like it will pass in this one, and then it will pass in this one. And so now I can talk about broadcasting a little bit, so we can go over that a little bit. So let's say we have our array A, and you can see that. And so if we multiply it by, let's say, 3, what is it really doing? If we look at this, somehow magically we're multiplying all of these values by 3. What it's doing is called broadcasting, where it's taking a 2x4 and it's multiplying it by a single value, and it's taking this value and it's broadcasting it to all of the different things, because this is really a 2x4 and this is only a 1x1 if you think about it. So we can use this to our advantage when we're doing neural networks and stuff like that, because we can do something like let me redefine B. B is going to be a 1x4, and this will be a 2x4. So this is going to be let me print both of these so we can walk along with it. So you can see we've got 0, 1, 2, 3, 4, 5, 6, 7, and then we have our second array, which is just 0, 1, 2, 3. So what we're doing is we're doing a 2x4 times a 1x4. And so what does it decide to do when it's multiplying a mismatch like this? What it actually does is it multiplies all of this and it just sets it to the first row, and so we get 0, 1 times 1, 2 times 2, 3 times 3, and then it takes this again and it multiplies it by the bottom row, this one, the 4, 5, 6, 7. And so what it's doing is it's just shooting it out to all of the other rows that it's valid for. And so that's a valuable tool for us to use when we're doing machine learning, because we might have one operation that we're doing a lot, and so we can just stack them all together and then run them in sequence, and it will just broadcast them out to the rest of the values instead of needing to do a for loop or something else like that. Then one other thing we can do is called masking, and this is really useful if you want to do some sort of filter or something like that. So let's say we're looking at our array A, this one right here, and we only want to show values that are greater than 3, let's say. So if we do greater than 3, what do you think it's going to do? Actually, what it does is it switches it to Boolean values. So we can see that it went false, 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 because those are all less than 3. And then this is 4, 5, 6, 7, and those are all true. And so that's pretty interesting on its own, because that can let you do some sort of filtering. We can do other kinds of functions instead of just greater than or less than. We can say, if this value is equal to this specific thing, then mark it as true. So if you have something that you're trying to filter for, you can use that. And what's even more valuable than that is we can do, let's say A, open brackets, close brackets, and what this does is it's indexing the mask onto our array. So what it's going to do is basically it's going to just eliminate all of the values that are false and only return the ones that are true. And so you can see this here where it got rid of the entire first row because all of that was less than 3 and all of these are greater than 3. So we got our 4, 5, 6, 7 back. And so that's really valuable if you have some large array. You're looking for some instance where a value is equal to something or greater than something or whatever other kind of filter you want. And so we can use this tool in order to make sure that we return those values. I think that should be it for our NumPy series. We've covered pretty much everything that I view as valuable, at least for machine learning right now. So after this, we're going to jump in and probably start doing some machine learning. Hopefully this was helpful, and see you next time.